All right, so I'm on page 13 of your packet. So, radical and rational equations solving. Now, when they say rational equation, they're really just talking about another way to write a radical equation. They're just using fractional exponents. When you get to math 3, rational equations kind of have a little bit of a different meaning. All right. So, why are we learning about radicals? Well, we just finished up a whole unit of quadratics. And now we're talking about the square roots. Now, why do you think those two connect? What connects a quadratic function to a square root function? What do you think? Think about what's typically in a quadratic function. So when you think quadratic function, what does a quadratic function always have? What type of exponent? A square. So it has an x squared somewhere in it. Now, square root function, what do you think it's always going to have? A square root. How do you think they connect? Square and a square root, they're not the same thing, but they are what to each other? Opposites. So they're inverses of each other. So in other words, if we want to take the inverse of a quadratic, we would get a square root function and vice versa. All right. So again, equations involving square roots arise in a variety of contexts. And solving these equations lies in applications of inverse operations. All right. So inverse relationship in these equations that are between taking a square root and squaring. All right. So like when we were solving quadratics, a lot of times one of our last steps was taking that square root. Well, now we're backwards. All right. So instead of taking the square root, we're going to be squaring. All right. So let's just look at some basic ones. So let's look at letter A. This is probably the most basic version. So I need to get the x by itself. So what do you think I'm going to do to get rid of that square root over the x? Square both sides. So I'm going to square the square root and square the 7. What happens to the square and the square root? They cancel out. So I get x is equal to what? 49. Now, we don't have to put plus or minus because we only have to put plus or minus when we're going from square to square root. So we're taking the square root of a square. All right. But if you're squaring a square root, you don't have to because they already said that this 7 is going to be positive. So in other words, if I plug the 49 back in for x, they're saying I'm getting the positive version of that. So this will be my answer. Now, what's going on with B? It's still going to be a square root function, but how'd they write it? With a fractional exponent. So 1/2 is the same thing as what? A square root. So in other words, if you have anything raised to the 1/2 power, it's the same thing as taking the square root of that. So I'm going to rewrite this as the square root of x minus 3, because it's in parentheses, so I can write all of it under the radical, set equal to 5. Now, think about this carefully. What do you think my first step is? To get rid of the square root. Why do you think I would do that instead of adding the 3? Right, it's still under the radical. It's almost like it's in parentheses. You can't break it apart until you get rid of that square root. So we're going to go ahead and take the square of both sides. That goes away. I get x minus 3 is equal to what? 25. Then I add the 3. So x is equal to 28. All right, any questions so far? All right. Try C on your own. Just take a minute. Try letter C on your own. All right, thumbs up if you're ready. All right, one more minute. All right. Shh. Let's talk. So, Shelby, what was your first step here? Right, square both sides. So what happens to the square root and the square? Cancels. I get 2x minus 1 is equal to what? 16. All right, and then from here, it's just a two-step equation. So I add the 1. I get 2x is equal to 17. Divide by 2. X is equal to 17 halves. All right, any questions on that one? All right, let's look at letter D. Okay, so this one has the fractional exponents. We got to be careful when we rewrite this. Okay, how do you think I would rewrite this? Not the 3x, just the x. Why is it just the x and not the 3x? No parentheses. So this 1/2 is only being applied to the x. So this will be 3 square root of x minus 4 is equal to 20. Now, we got some stuff outside of the radical. All right. So remember when we were doing this with quadratics, think SADMEP. All right. Technically, the square root is our exponent in this case. All right. So based off of SADMEP, what would I have to do first? Add the 4 to both sides. So this would be 3 square root x is equal to 24. Then what do I do? Divide by 3. We're multiplying to the radical by 3, so we're going to divide by 3. Square root of x is equal to 8. Last step, square both sides. So x is equal to what? Good. So when you're rewriting, again, be very mindful if they have it as a fractional exponent, be very mindful about those parentheses. All right. If there's no parentheses around the 3x, the 1/2 only applies to whatever base it's connected to. All right. Walk me through this one. So again, think SADMEP. So what's my first step? Minus the 7. So I get 2 square root x plus 5 is equal to 6. Then what? Divide by 2. So I get the square root x plus 5 is equal to 3. Now what? Square both sides. So I get x plus 5 is equal to 9. And then I just subtract the 5. X is equal to 4. Oops. All right. Now, take a minute, look at letter G. What's different about letter G versus what we've been doing so far? It's a cube root. So when we get the cube root by itself, what do you think I'm going to do to undo it? Cube it. All right. So just like a square undoes a square root, a cube undoes a cube root. So essentially the trick is that whatever the index of your radical is, that's the power you're going to raise it to undo it. So if that was a 4, you'd raise it to the 4th power. If it was a 7, you'd raise it to the 7th power. All right. So my first step would be to subtract the 5. So I get the cube root of x minus 7 is equal to 4. Then I would take the cube of both sides. So the cube root and the cube cancel out, so I'm left with x minus 7. And what's 4 cubed? 64. And then my last step is to add the 7. So x is equal to 71. So like I said, whatever that index is, so the little number outside the radical, whatever that index is, that's the power you're going to raise that radical to undo it. So remember, with the square root, even though there's nothing outside of it, there's an unspoken 2 there as its index. But every other type of radical will have that little number. All right. Now, those were some fairly easy square root functions or square root equations or radical equations. But that's not always the case. So sometimes we have a more complicated scenario. So where we have a square root expression is equal to a linear expression. All right. So in other words, it's almost like we got a system. So we're going to solve this both graphically and algebraically. All right. So we're going to solve it graphically first. So we're going to consider these two equations. I'm going to graph the x plus 1 first because that's the easier one. So where do I start with the linear function? The y-intercept, which is 1. All right. What about, and then you just go up 1 over 1. And just go for a couple of points or until you run out of graph because you want this to be as accurate as possible. Now, let me ask you guys this. When it comes to graphing a square root function, what is the lowest number that I can have under the radical? So I'm not talking about what we plug in for x. I'm talking about what's the lowest number. If I plug a number in for x and evaluate it, what's the lowest number that I can have under the radical? Nope. 0. Why is it that I cannot go lower than the square root of 0? It'd be imaginary. Good. So what x value would give me 0 under the radical? -3. So a way you can figure that out is you set whatever's under the radical equal to 0. just like if we were solving a quadratic, x would equal -3. So that is what we call your lowest or your lower bound. So your x value cannot go past -3. Because, for example, if I put in -4 in for x, what would I get? So if I plug in x is equal to -4, what would I get under the radical? -1. And we know the square root of -1 is I. Good. So that means that for our table, we have to start with -3 for x. And then we go up. So if I plug in -3 for x, -3 plus 3 is 0. What's the square root of 0? 0. All right. Then I'll go to -2. -2 plus 3 is +1. What's the square root of 1? 1. All right. Then -1. -1 plus 3? 2. What's the square root of, well, we'll just leave it as square root of 2. We probably won't graph that one. All right. 0. So it'd be the square root of 3. 1. So what's the square root of 4? 2. All right, so let's just graph what we have so far yet. I'm only going to graph the nice numbers. I'm not going to really bother with with the irrational numbers. So I got -3, 0, -2, 1, 1, 2. Now, what's another number that I can plug in for x that would give me a perfect square? So 6. Why 6? Right. If I plug in 6, 6 plus 3 is 9. Square root of 9 is 3. So then I'll go over 6 and then go up 3. And we'd run out of graph at that point. So my square root function is going to look like this. Now, there's one other thing I want to note. What I tell you happens if you take the square root of a number. What technically goes in front of it? A plus or minus. So on the flip side of that, we're also going to graph the plus or minus version. Now, I'm going to do this in a different color for reasons. So I got -2, -1, 1, -2, and 6, -3. So what does that square root graph look like to you? It looks like a parabola, but it's turned on its side. All right. So if I solve this system graphically, what do I got? All right. So I got -2, -1, and I got 1, 2. Because remember, if you're solving a system, you need an x and a y. So xy is equal to the 2 points of -2, -1, and 1, 2. Now, that was if we solved it graphically. But let's solve it algebraically. All right, so we're going to solve it by substitution, which is just a fancy way of saying since they both are equal to y, we're just going to set them equal to each other. So if I have the square root of x plus 3, I'm going to set it equal to x plus 1. Now, here's the deal. We just need to get rid of the square root first. All right? Because it's just ugly, and we know how to handle quadratic equations, which is what will happen when we get rid of the square root. It'll create a quadratic equation. So I'm going to go ahead and take the square root of both sides. So if the square root is already by itself on one side, just take the square root of both sides, even if you have a variable on the other side. So the left side becomes x plus 3. What does the right side become if I... Nope. What's x plus 1 squared the same thing as? No.
X plus 1 plus x plus 1.
X plus 1 times x plus 1. So guys, you cannot forget that. You do not just do power rule with that. So if we did a quick box method or FOIL it, we get x squared plus 2x plus 1. Then we would subtract the x and the 3 to both sides. Because we got to get one side equal to 0. So this would be 0 is equal to x squared plus x minus 2. Now, if I factor this very quickly, what are two factors that multiply negative 2 add to 1? 2 and negative 1. Good. So this would be x plus 2 times x minus 1 is equal to 0. So x would be equal to the set of negative 2 and positive 1. We then plug it back into one of our equations to get the y's. So I'm going to plug it into the x plus 1. So that means that the y's are negative 1, because negative 2 plus 1 is negative 1, and 2. So the point xy would be equal to pretty much the same thing that we got. Now, here's the thing. Here's kind of the issue that we have. If you were to graph that square root function in Desmos, they would only give you this part. Why do you think they only give us that part of the square root function? Well, it is the positive version. All right. All right. But also think about it this way. If I plug in, who remembers what's special about a function? Because it's a square root function. Why is it a square root function? So there's one thing that always has to happen in functions. It's review from Math 1. In order for a function to be a function, one thing cannot happen. Does anyone know what it is? Think VLT.
There cannot be 2 points on the same y-axis.
Close. VLT stands for vertical line test. Think about that. That's how you check for a function. Right. You cannot have repeating x's. All right. So, because of that, typically when you're evaluating a square root, you're taking the positive version of that square root. All right. So, technically, what I have in purple here would not exist. So, what would happen is because of that, this point or that point of intersection did not happen. Because I'm looking at the actual square root function, which is the positive version of it. All right. So what contradicted? Well, if you solve graphically, you would only have 1 point. And if you solved algebraically, you would have 2 points. So if I gave you something like this, how would you know which point to use? Well, you would essentially pick whichever one would give it to you positively. Also, real quick, do me a favor, plug the x values back into the square root function. So the two x values we got were -2 and +1. I want you guys to plug it back into both functions. So plug it into the square root of x plus 3 and x plus 1. Just do me a favor, plug that back into both. Tell me what you get. So if I plug -2 back in, this would be the square root of 1, which is what? 1. However, what's -2 plus 1? -1. Do those match? So if this was a system, we're saying that 1's equal to -1. Do those match? No, there's the contradiction as well. So that's why if we looked at it graphically, it would only end up with 1 point instead of 2 points. That's our contradiction. Whereas if I plug the 1 in, I would have 1 plus 3, which is square root of 4, which is 2. And then 1 plus 1 is still 2. So those are equal. So this is true. But the other one is not. This is what we call an extraneous solution. It's essentially a solution that when you plug it back in, it does not give you both sides equal to each other, or it makes something undefined or something in that sense. All right. So x equals -2 is considered an extraneous solution, even though we technically get a point on a graph. But you got to remember that what I highlighted in yellow, that's the true graph of a square root. So get into the habit with square root functions of plugging your x values back in to your original equation. And make sure that both sides are equal to each other. So, like I just said, these roots are known as extraneous and can always be found by checking in the original equation. All right, so let's do these two together. So letter A is similar to the one we just did. So I got a linear on one side, a square root on the other. So what do you think I'm going to do first? I need to get rid of the square root, so I'm going to square both sides. Claire, can you shut the door, please? So I'm going to square both sides. So this would be 2x minus 3 is equal to what? If I did a quick FOIL on x minus 3 times x minus 3, what is it?
Square root minus 6 plus 9.
Right. X squared minus 6x plus 9. It's a perfect square trinomial, so that should be fairly quick. Then I get one side equal to 0. That goes away, so 0 is equal to x squared minus 8x plus 12. So what are two factors of 12 that add to negative 8? Negative 6 and negative 2. So this would be x minus 2 times x minus 8. So x is equal to the set of positive 2 and positive 8. Now, I am not going to claim that's my answer yet, because what do I need to do? Oh, oopsie. So I'm not claiming these as my solutions yet, because what do I need to do? Well, this isn't really a system. We're just solving for x. But we need to do what? Plug it back in and check for extraneous. So we got to check for extraneous solutions. So I'm going to plug in 2 in first. So we're checking x equals 2. So the square root of 2 times 2 minus 3 is equal to 2 minus 3. So what's 2 times 2? 4. 4 minus 3? Square root of 1. This is 1 is equal to, what's 2 minus 3? Negative 1. Is that true statement? Nope. So x equals 2 is extraneous. What do we do with extraneous solutions? We throw them out. So it's no longer part of my solution set. Now I'm going to check when x is equal to 6. So 2 times 6 minus 3 is equal to 6 minus 3. So what's 2 times 6? Minus 3?
9.
9. Square root of 9? 3. What's 6 minus 3? 3. Is that a true statement? Yep. So 6 is my solution. Not always. So there's some cases where you have no solution because they both don't work. So you have to check both. No, there probably would be. It depends on what the function is. It's very rare that there's 2 of them, but it can still happen. So I wouldn't throw out the possibility. So guys, you gotta check both. There's really no shortcuts for this. And you don't have to flat out write out the check. You can just do a quick check in your head. All right? Like, just do some mental math and do it that way. All right? Try this one on your own and check for extraneous. So I'll give you a hint. Get the radical by itself first before you square both sides. So get the radical by itself first before you square both sides. So nothing outside that radical. All right, thumbs up if you're ready. Okay, one more minute. All right, so for time's sake, we're going to move on. All right, so first things first, before I can take a square root, I got to do, not take a square root, before I can take a square both sides, what do I have to do first? Add that 2 to both sides. So we got to get the radical by itself before we can square it. So this will be 2x plus 2 is equal to the square root of x plus 6. Now I can take my squares. That goes away. I get 4x squared plus 8x plus 4 is equal to x plus 6. Now what do? Move everything to the other side. So I get one side equal to 0. So I'm going to subtract the x, subtract the 6. That goes away. I get 4x squared plus 8x, plus 7x minus 2 is equal to 0. Now I can factor. So, what goes on top? -8, bottom. 2 factors that multiply -8, add to 7. 8 and -1. So this would be 4x squared plus 8 minus 1x minus 2. Yeah, I forgot to put the x. Do a quick grouping. So this will be 4x, x plus 2, -1, x plus 2. So my 2 factors are 4x minus 1 and x plus 2. So set both equal to 0 and solve them. I should get x is equal to, right, so positive 1/4 and -2. Now, I still need to check them, so I'm going to do a quick throw back into my original equation. All right? So when I say original, I mean what they wrote up here before you did anything. So, I have 2 times 1/4. Ladies, please stop talking. Is equal to the square root of 1/4 plus 6 minus 2. So what's 2 times 1/4? 2/4 or 1/2. Now this takes a little legwork, but if you change 6 to have a denominator of 4, it'd be 24 over 4. So that's 25 over 4. So what is the square root of 25 over 4? So remember, take the square root of the top and the bottom. 5 over 2. You could, but it's still have to deal with fractions. And then 5/2 minus 2. So that means I'm subtracting 4 over 2. So what's 5 minus 4 over 2? So what's 5/2 minus 4/2? 1/2. Shh. So is it true that 1/2 equals 1/2? Yes. So x equals -4, probably, sorry. X equals 1/4 works. Now I got to check -2. So what's 2 times -2? -4. Now, -2 plus 6 minus 2. What's -2 plus 6? 4. What's the square root of 4? 2. What's 2 minus 2? 0. Is -4 equal to 0? Nope. This one's gone. So my answer is x is equal to 1/4. So guys, even if it's a matter of just throwing it in your calculator really quickly, that's fine too. You don't actually have to physically write it out, but you need to use the original equation. All right, because sometimes when we start manipulating stuff, that's when it gets a little funky and what you'll get. So always use the original equation when you plug stuff back in. All right, last little bit and then we're done. Yeah. All right. So just for some formal steps on solving, if you have one radical in the problem, isolate it to one side of the equal sign. And if you have two radicals in the problem, put one on each side. So one radical you isolate to one side, two radicals you put one on each side. Because we will see one in just a second where you have two radicals on both sides. Or a radical on both sides. Then use the opposite power to remove the radical. So again, that's based off of the index. So whatever the index is, that's the power you raise it to. So if it was a cube root, the index is 3, you raise it to the third power. Fourth root, index is 4, raise it to the fourth power. Now, use the reciprocal power to remove fractional exponents. And consider whether it's positive or negative. So in other words, if you have a fractional exponent that's not like 1 over a number, like it's like 2 over 3 or something, you would raise it to its reciprocal power. Now, the resulting equation, you may have to possibly solve by factoring. And then lastly, and this is probably the most important, check your answers because there could be possible extraneous solutions. So let's look at example 5. So I'm actually not going to convert the x to the 3/4 to a radical. And you'll see why in just a second. So first things first, I gotta get this by itself. So what do I need to do first? Add the 7. So I get 2x to the 3/4 is equal to 16. Then I do what? I have no clue. Divide by 2. So x to the 3/4 is equal to 8. All right. Now, I then have to get rid of the 3/4. So I need to multiply or raise both sides to its reciprocal power. So what's the reciprocal of 3/4? 4/3. Now, why do I multiply by the reciprocal? What happens when I do that power rule? It cancels out because it becomes what? Not 0, 1. So these cancel. So x is equal to, how do I write this? What's my index? 3 is my index, and it's raised to the power of 4. So remember, my recommendation, do the root first. So what's the cube root of 8? 2. So what's 2 to the 4th? 16. All right, if I do a quick check back in, I have the 4th root of 16, which is 2, raised to the third power, which is 8. 2 times 8 is 16, minus 7 is 9, so it works. So this is my answer. All right. No, it's just exponent rules on the quiz. So 5.1, 5.2. All right, let's try another one. Look at example 8. So again, think SADMEP while we're doing this. So what's my first step? Add the 3 to both sides. So I get 4 times x minus 7 to the 2/5 power is equal to 16. Then what do I do? Divide by 4. So I get x minus 7 to the 2/5 power is equal to 4. How do I get rid of the power 2/5? Raise it to what? The reciprocal, which is 5/2. So I'm raising both to the 5/2 power. So that goes away. I get x minus 7 is equal to, what's for the 5/2 power if I rewrite it as a radical? Square root of 4 to the 5th power. So what's the square root of 4? What's 2 to the 5th? 32. So x minus 7 is equal to 32. And again, guys, if this was with the calculator, you could just put that in your calculator too. I'm just showing you how you can do it in your head. But by all means, put it in your calculator. So then I'm going to add 7 to both sides. X is equal to 39. If I do a quick check of that, 39 minus 7 is 32. The 5th root of 32 is 2. 2 squared is 4. 4 times 4 is 16. Minus 3 is 13. It works. All right, last one. So now I'm not going to solve number 9 because I really want to do number 10. But number 9, what do you think my first step is going to be if I have 2 square roots on both sides? Square both sides. And if that happens, we're just left with the nice linear equation, which I know y'all are fully capable of solving. All right. So we're not going to finish working that one out. I just want you to know that if it's on both sides, just square it. It becomes a nice linear. Yes. Yeah. Now, 10 is the one I want to do. So I have 2 cube roots on one side. So what do you think I'm going to have to do to one of the cube roots? Nope. I need to put one on the other side. So I need to add or subtract the other one to the other side. So which one do you think I should move? The cube root of x. So I'm going to add the cube root of x to the other side, which you can totally do. It's just like if you were moving an x squared. So I get the cube root of 3x plus 7 is equal to the cube root of x. Now what can I do to get rid of the cube roots? Cube both sides. So this goes away, this goes away. I get 3x plus 7 is equal to x. I can subtract the x over. Get 3, not 3. I get 2x plus 7 is equal to 0. Minus 7 to the other side. 2x is equal to negative 7. So x is equal to negative 7/2. Now, I'll let you guys put that in your calculator because it's probably not going to be pretty numbers to check. So that's definitely one you want to put in your calculator. But it should work. Because remember, cubes can be negative. All right, any questions on any of this? All right, so your homework for tonight is page 16 and 17. So you guys got a solid 20 minutes. So I'm going to come around and check off your homework from yesterday while you guys start working on this. So yesterday was page 11 and 12.